Okay, let's do another integral with a u substitution. Here's our integral, x e to the x squared dx. Try this one on your own first, hit pause on the video, and then rejoin after you've given it a minute or two thought, have an answer or not, but I would like you to really try before you watch me do it. Okay, so you're back, you've time traveled forward, and now we're ready to do this together. So we have two problems here, and from our rules of integration we know we have these two problems. We have a multiply. And we don't have any rule for f times g. Had that in derivatives, but no such thing in integrals. So we don't have a product rule for integrals. So we're going to have to do something else. And we have e to the x squared. With derivatives, that would have been easy. We do chain rule, e to the x squared times the derivative of x squared, and you just ignore that and then take its derivative later. But we don't have a chain rule for integrals either. So some kind of way we have two problems we have to resolve. And as mentioned in the first one, we look for something whose derivative is in the problem in a substitution. And in this case, the derivative of x squared would be 2x. And I don't quite have 2x, but I can always fix a constant. Constants move in and out of integrals at will, so that shouldn't be too bad. Let's just give it a try. U equals x squared. Now, this, from experience, you're seeing me pick the right substitution because these problems, I've done them before. I've done them for 15 years, so of course I know which substitution to do. But in your case, if you pick a wrong substitution and you get a du and you can't make it work out, that's okay. You didn't mess up a problem. You simply went down a path that didn't get to the answer, and you come back and try another substitution. So someone might let u equal e to the x squared. U equal x isn't typically going to do much. That's just rewriting a variable. But there are other substitutions often in problems that could be tried, and in some problems that might be the right one. So if you're stuck in a problem like this, try something. That's the moral of this long rambling story, is let u equal something and give it a shot. If it doesn't work out, cross it out. In my case, I erase a whiteboard and start over. So u equals x squared du equals 2x dx. So I'm liking u equals x squared, because then I have e to the u. E to a simple variable, I'll be able to take the integral of. And 2x dx, we've got x and I've got dx, but I don't have a 2. So let's see if we can fix this. I need a 2. Can I just put a 2 inside an integral and without changing it? Well, of course not. But what if I put a 1/2 outside? 1/2 times 2 is 1. And one of our rules is that a constant can move in and out of an integral. So 1/2 times 2 is 1 is no change to anything. And I write the rest of the problem down. And you can see this is still the same problem. We just put the 1/2 back in, which it has every right to do since we have that rule of integration. And we're back to the original problem. So here we have 2x dx, which is my du. And I have u as x squared. So I could rewrite this 1/2 the integral e to the u du. We like this one a lot because that's an easy integral. Integral e to the u, or e to the x, and e to a variable is itself. So 1/2 e to the u plus a constant. Now we don't leave our answer in u, we substitute back to where we were, and we get 1/2 e to the x squared plus a constant. Let's check our work. Derivative of a constant is 0, not an issue. E to the x squared's derivative is e to the x squared times the derivative of x squared, which would be 2x. 2 and a 1/2 would cancel, x e to the x squared. Perfect. Now I'm just verbalizing it. You can feel free to write this down, and as a good practice of your chain rule for derivatives, make sure that it actually equals our previous answer. You can always check your rules, your answer on an integration problem by taking the derivative.